Alrighty, so I'm working on example 2 in this video. This one is going to change the period, so this will be a handy one to kind of practice this skill, and I will go through and show both a method of kind of the intuitive method of cutting things in half and also a calculator method so that you can see that one as well, so that hopefully one of these methods works out for you here. Alright, so cosecant is going to be based off of the sine graph, since it's the reciprocal of sine, which means I'm using the same period formula for sine, and I'm going to be filling in my sine key points here. All right, so 2 pi over b is going to be my formula, and I can just refer on my pink sheet, there it is, to this formula here with secant and cosecant. B in this case is this 2, so 2 pi divided by 2 would be pi. That's going to go at the bottom of my table with 0 at the top. Alrighty, if I do the kind of intuitive version of this, I could cut this in half, get pi over 2. Again, thinking like 1 cup, half of that would be a half a cup. Half of that, half of a half cup, would be a quarter cup. So pi over 4 is what I'm thinking for there. And then halfway between a half and 1, this would be like 0.5 and 1. This would be like 0.75, so that would be 3 pi over 4, 3/4 cup kind of thinking. All right. Again, I said I would show you kind of the calculator version of that. If you wanted to do the interval and kind of do that with your calculator, remember we take the period, and to do the interval, we do the period divided by 4, cut into 4 parts. So period divided by 4 is just going to be pi over 4. And I can kind of think 1/4 for that. So you can literally start at 0, 0 plus 1/4, and that gives you 0.25. If you math frac that, it's got to 1/4, which makes sense because 0 plus anything is just going to be that value. Okay, now add another 1/4 to that. So that's going to give me 0.5. All right, math frac it if you want, and you convert it over to 1/2. Add another 1/4. Math frac it, and that's going to be the 3/4 that I had there. And then I can just verify another 1/4 takes me to 1 and pi. So that's how I would do the process if you like more of a calculator algorithm that would allow you to use that. All right, back to this one. So I'm ready to start labeling my axes here. So I'm going from 0 to pi for my first cycle, which means I need to double it for my second cycle. Cool. All right, and then halfway between 0 and pi would be pi over 2. That's going to be this value here. Now, halfway between pi and 2 pi, we might have an idea of what that might be, but if I were having trouble thinking of that, I'd think, okay, I've got 1/2, that's like 0.5, then 1, then something, and then 2. What's going to be halfway between 1 and 2 if I'm kind of following this pattern? Well, 0.5, 1, something, 2, halfway in between will be 1.5. If I type that in my calculator and math bracket, that's going to give me 3 over 2. And just put on the pi. Cool. All right. I'm going to be filling in my sine points. You can refer back to your pink sheet. It's got your sine points right there. So 0, 1, 0, -1, 0. Maybe have those memorized still. All right. Next column is going to be A column and D column. A value here in this case is -1. So you're going to be multiplying by -1. And then there is no D value because we're not doing any kind of vertical shift. So I can write none for that, and I can also fill in none for our phase shift. So not going to use that column at all. All right, multiply these points, 0, -1, 0, 1, 0, and I am keeping all 5 points so that I have all of them to graph. All right, I'm going to switch colors and do my sine graph in blue. So 0, 0, pi over 4 and -1, pi over 2 and 0, 3 pi over 4 and 1, pi and 0. Cool, one cycle followed through there. I can kind of tell my sinusoidal is here at 0. So y equals 0 for my sinusoidal. All right, following through that cycle, matching those up. Then I'm going down for my next tick. Then back up to the sinusoidal. Then back up here. Then back down to the middle. And I'll kind of connect those just to have the general curve in between. Cool. All right, so that is our sine graph. It is reflected. We can tell that. On we go. We are now ready to mark our asymptotes in here. Now, your asymptotes are going to happen everywhere you have zeros there, everywhere that we had zeros for our sine points, which is also where you see the points where the sine curve crosses the sinusoidal axis. So here, 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 and here. So at 0, pi over 2, pi, 3 pi over 2, and 2 pi, we have all of those asymptotes. So I'm going to get those. I'll do my best to make nice straight vertical lines. Cool. All right, so that's what we've got there. So then I'll list those. I'm going to list the ones from my table. So I'm going to be listing these values as asymptotes. So I'm going to have 3 asymptotes that I'm going to be listing here. X equals 0, x equals pi over 2, and x equals pi. You are going to have 3 asymptotes, where in the last example, example 1, we only had 2. And that is different because of the structure of sine versus the structure of cosine. All right. Then I've got my curves that I need to add in. I'm going to, again, switch colors here and draw these parabolas in, fitting in between the asymptotes and starting them off kind of like a vertex of that parabola at each of these points from our table. So these are going to turn into my key points here. Pi over 4 and negative 1, 3 pi over 4, and 1. I don't totally care what order you put these in. Some people like to put these in order of the table, but I kind of like keeping the points separate and keeping the asymptotes separate, just because it kind of helps me remember to write all of these the right way versus ordered pairs for those. All right, finish off my parabolas. And here we are. All right, domain. Oh, I skipped amplitude. That's going to be 1. Same as it has been. Negative 1. Got to be positive. All right, domain. Remember, we're listing the things x can't be from our table for this first cycle. So it's going to be all of my asymptotes. That's why I'm going to put this in purple. X cannot be 0, pi over 2, and pi. And then for my range, I'm going all the way towards negative infinity. Cutoff here looks like it's at 1. Restart at 1, and then up to infinity. So I'm just going to list these values out using my structure. I can look back at my pink sheet if I want to model. Negative infinity to negative 1, bracket, u, bracket, 1 to infinity. All right, there we go. That's example 2. Stay tuned for example 3.